This experiment was supposed to be impossible until now. And the reason it matters has less to do with machines and more to do with you. Because at its core, this story is not just about a lab result. It is about the hidden rules your brain lives by and how close science has come to touching the edges of those rules. Imagine being told for decades that a certain boundary could never be crossed. Not because of lack of technology, but because of biology. Because the human brain simply would not allow it. For years, neuroscientists believed there were hard limits to perception, adaptation, and stress tolerance. Lines written deep into neural circuits that evolution itself would not let us erase. Yet recently an experiment challenged that belief. Not loudly, not sensationally, but quietly with data. And what it revealed was unsettling in the most fascinating way possible. Because it suggests that what we call impossible may simply be a protective illusion created by the brain itself. The experiment began with a simple question. What happens when the brain is placed in conditions it believes are unsustainable, not physically impossible, but cognitively overwhelming? Conditions where perception, stress, and uncertainty collide. Traditional models predicted failure, overload, breakdown. The brain shutting down its own systems to prevent damage. This idea is central to neuroscience, the brain as a regulator. A system designed not for maximum performance but for survival. Like a circuit breaker in an electrical grid. It cuts power before the wires melt. And for most of human history, this made perfect sense. Stress hormones spike. Attention narrows, perception distorts, and performance drops. The mind pulls back. This is why extreme stress makes time feel strange. Why fear blurs vision. Why exhaustion feels like a wall you cannot push through. Neuroscience taught us that these limits are fixed thresholds tied to neurochemistry, cortisol levels, synaptic fatigue, metabolic constraints. But the experiment did something different. It did not try to force the brain past its limits. It tried to listen to them. Researchers designed an environment where participants were exposed to sustained cognitive stress, sensory ambiguity, and controlled uncertainty. Not all at once, but gradually. Like increasing the load on a bridge one molecule at a time, while continuously monitoring neural activity using high-resolution imaging and electrophysiology. What they saw challenged decades of assumptions. Instead of a uniform shutdown, the brain reorganized networks. Regions typically associated with rest began communicating with areas linked to high-level problem-solving. Perception pathways rerouted. Stress circuits dampened themselves. This was not the brain breaking. It was the brain adapting in real time, reshaping itself in ways previously thought impossible. This is where neuroplasticity moves from a buzzword to a measurable force. Neuroplasticity is often described as the brain's ability to change. But that definition is almost insultingly simple. What plasticity really means is that the brain is a dynamic prediction machine constantly updating its model of reality. Under stress, the brain does not ask how hard is this. It asks how dangerous is this. If a situation is labeled as lethal, systems shut down. If it is labeled as survivable, systems adapt. The experiment showed that many limits we experience are not structural failures but predictive safety mechanisms. The brain decides in advance how much energy, risk, and uncertainty it is willing to tolerate, and then enforces that decision through perception, fatigue, pain, and fear. In this sense, perception itself is not a window to reality. It is a dashboard, a curated interface designed to keep the system stable. When stress rises, perception narrows. Not because reality narrows, but because the brain reduces bandwidth to prevent overload. Like a network throttling data to avoid collapse. This reframes the idea of human limitation. The brain is not a rigid machine with fixed spec. It is an adaptive energy network constantly reallocating resources. Thoughts are signals, stress is feedback, and consciousness is the control room. The experiment revealed that when the brain is gently convinced that a situation is safe enough to explore rather than escape, it unlocks capacities that were always there, but hidden behind protective barriers. This does not mean humans have infinite potential. That would be a myth. But it does mean our perceived ceilings are often lower than our actual ones. Psychology has long hinted at this phenomenon. Placebo effects show belief-altering physiology. Flow states show performance exceeding normal limits. But this experiment provided neural evidence. The twist lies here. The moments when you feel weakest, overwhelmed, frozen, exhausted, may not be signs of failure. They may be signs that your brain is actively protecting you, reducing output to preserve the system. The brain evolved not to make you happy or powerful, but to keep you alive. And survival favors caution over optimization. The experiment demonstrated that when the brain recalibrates its threat assessment, those same systems can reopen channels, restore perception, and sustain performance under conditions once thought impossible. This has implications far beyond the lab. It reshapes how we understand burnout, anxiety, learning, even creativity. Chronic stress, for example, may not damage the brain directly, but may lock it into a perpetual safety mode, narrowing perception and limiting adaptability. Conversely, environments that signal safety even under challenge may promote neural flexibility, expanding cognitive range. This aligns with biological principles seen everywhere. Muscles grow not when stressed to destruction, but when stress is paired with recovery. Ecosystems thrive not in constant catastrophe, but in dynamic balance. The human brain is no different. It is an energy system operating under constraints, constantly negotiating between risk and reward. What makes this discovery profound is its philosophical echo. For centuries, thinkers debated whether human limits were intrinsic or imposed, whether consciousness was bound by nature or capable of transcending itself. Science now suggests a third answer. Limits exist, but many are negotiable, not through force, but through understanding. The brain does not respond to command. It responds to context. When context changes, circuits change. This is why fear can make a calm person irrational, and why trust can make an ordinary mind extraordinary. The experiment also touches quantum metaphors. Not because the brain is quantum magic, but because, like quantum systems, it operates probabilistically. Perception collapses multiple possibilities into a single experience based on expectation, prediction, and prior belief. Stress skews those probabilities, making negative outcomes more likely to be perceived. Safety broadens them, allowing new patterns to emerge. The brain is less like a static object and more like a constantly updating wave of activity shaped by internal and external signals. When scientists once said this experiment was impossible, they were not wrong, based on old models. Those models assumed fixed thresholds, fixed wiring, fixed responses. But biology rarely respects static models. Life adapts by definition. What changed was not the brain, but our way of asking questions. Instead of asking how much can the brain endure, researchers asked under what conditions does the brain choose to endure. And that shift made all the difference. This brings us back to you, because this is not just about extreme experiments or elite performance. It is about everyday perception. When you think you cannot focus anymore, cannot learn anymore, cannot handle one more challenge, that feeling may be real, but its cause may not be what you think. It may not be a lack of capacity, but a signal of perceived threat, the brain pulling the brakes. Not because the road ends, but because it predicts danger ahead. The question then becomes, how often do we mistake protection for limitation? How often do we identify with the brain's safety signals as truths about who we are, rather than temporary states? This does not mean ignoring stress or pushing endlessly. That would be misunderstanding the lesson. The point is respect the system. Understand its language. Stress, fatigue, fear are not enemies. They are messages. And when decoded properly, they can guide adaptation rather than shut down. The experiment did not break the brain. It collaborated with it. And that collaboration revealed a deeper intelligence at work. An intelligence shaped by millions of years of survival, yet flexible enough to surprise even its own creators. So, the next time you encounter an edge, a moment that feels impossible, consider this. Maybe you are not at the limit. Maybe you are at a checkpoint, a place where the brain is asking for context, reassurance, and meaning before it reallocates energy and opens new pathways. Science is beginning to show that the boundaries of human capability are not walls but doors. And doors respond not to force but to the right key. And that key is understanding. If this idea made you pause, if it shifted how you think about your own limits, ask yourself what other impossibilities might simply be misunderstood protections. And if you want to explore more experiments like this, more neuroscience, psychology, and science-driven insights that challenge how you see your mind, then like this video. Share your thoughts in the comments, and subscribe to MindSpark Science, because the most powerful discoveries are not just out there in laboratories. They are happening quietly inside your own brain right now.